Hey there, and welcome. Ever looked at a list of decimal numbers and felt your brain just kind of freeze up? Well, if you have, you are definitely not alone. But guess what? That's all about to change. Today, we're going to break it all down and turn that tricky task into a skill you can feel really confident about. So let's just dive right in. So, here's what we're going to cover. We'll kick things off with a real world problem, a decimal dilemma, if you will. Then we'll walk through a couple of key strategies to solve it. We'll even look at something called Eureka's zero trick. It's a game changer. After that, we'll tackle mixed measurements, and by the end, you'll be a decimal pro. Sound good? Let's go. So, our story begins where speed is everything, the athletics track. Yeah, it's all about time. We've got this list of times from a women's 100-meter sprint, and our job is to figure out who came in first, second, third, and so on. So the question is simple enough, right? Who's the fastest runner? But when you're dealing with fractions of a second, how can you be sure you're getting it right? How do you spot the winner without any doubt? Okay, take a look at these times. Look at them. They all start with 10, and the numbers after the decimal are all super close. Your eyes kind of jump all over the place, and it's really hard to just know who won instantly. And here's the key thing to remember with races. The smallest number is the fastest time. We're looking for the lowest value. And that is exactly why we need a system. This isn't about guesswork. It's about having a foolproof strategy, a clear set of steps you can follow every single time. It works for race times, it works for money, it works for anything with decimals. All right, that brings us to our very first strategy. And honestly, this is the easiest one, but it's so important. It's always, always the first thing you should do. So here it is, the whole number rule. It's simple. Before you even think about looking at the numbers after the decimal point, just compare the whole numbers. You know, the numbers to the left of the decimal. Seriously, a lot of the time, this one step is all you'll need to solve the whole thing. Okay, let's look at an example. We've got these three numbers, 6.45, 8.9, and 14.639. So, using our new rule, let's just totally ignore everything after the decimal for a minute. What are the whole numbers? We have a 6, an 8, and a 14. Well, ordering those is a piece of cake, right? 6 is smaller than 8, and 8 is smaller than 14. And just like that, we're done. The correct order has to be 6.45, then 8.9, then 14.639. We solve the whole thing just by looking at the whole numbers. See how powerful that simple first step is? All right, that first strategy is great when it works. But what happens when it doesn't? What do you do when all the whole numbers are exactly the same? And this is the exact problem we have with our race times, isn't it? Every single one of them starts with a 1. So comparing the whole numbers doesn't get us anywhere. We need to dig a little deeper. The key to digging deeper is all about place value. You got to remember what each column means. Right after the decimal point, you've got the tenths, then the hundredths, then the thousandths, and so on. This table is basically our roadmap for comparing the rest of the number. Okay, let's try this with a new example. We're comparing 2.82, 2.6, and 2.816. See, they all start with a 2, so our real work starts after that decimal point. So here's the system. You move from left to right, one column at a time. So let's look at the very first column after the decimal, the tenths place. We've got an 8, a 6, and another 8. Well, the 6 is definitely the smallest one there. So boom, we know that 2.6 is the smallest number of the bunch. Okay, so we've got 2.6 sorted. Now we just have to compare the other two, 2.82 and 2.816. Their tenths digits are both 8, so that's a tie. We have to move to the next column, the hundredths. In 2.82, we have a 2. In 2.816, we have a 1. Well, 1 is smaller than 2, so that settles it. 2.816 comes next. And that's it. The final order is 2.6, then 2.816, and finally 2.82. By going column by column, you can't go wrong. It's a foolproof method. Okay, that column by column method works perfectly. But what if I told you there was a shortcut? A really cool visual trick that makes the whole thing feel way easier. It's called Eureka's zero trick, and it's awesome. Here's how it works, and it's so simple. Step 1, find the number with the most decimal places. Step 2, add zeros to the end of the other numbers so they all have the same number of decimal places. Step 3, now you can just compare the numbers after the decimal point as if they were plain old whole numbers. Just look at the difference this makes. On the left, before the trick, the numbers look kind of jumbled. They have different lengths. But on the right, after we've added those zeros, look how clean that is. 4.23 becomes 4.230, 4.6 becomes 4.600. Now they all have 3 decimal places. Everything lines up perfectly. And here's the best part. Now you can pretty much ignore the 4 point and just compare the numbers 179, 230, and 600. I mean, how easy is that to order? Obviously, 179 is the smallest, then 230, and then 600. So that means the order of our original numbers is 4.179, 4.23, and 4.6. It's such a brilliant little trick. All right, so you're getting pretty good at this decimal thing. Let's put those new skills to the test with a slightly different kind of problem, ordering measurements when they're in different units. So how would you order these? We've got 50 centimeters, 0.4 meters, and 345 millimeters. You can't just compare 50, 0.4, and 345, right? It's like comparing apples, oranges, and, I don't know, bananas. It just doesn't work until you do one very important first step. And that one crucial step is this. You have to convert everything to the same unit. It doesn't really matter which one you pick, meters, centimeters, whatever, as long as they're all consistent. For this, we'll need to remember our conversions, like how many centimeters are in a meter. Okay, let's do the conversions. We'll change everything to centimeters. So 0.4 meters, well, that's 40 centimeters, and 345 millimeters, that's 34.5 centimeters. So now our list is 50 centimeters, 40 centimeters, and 34.5 centimeters. See? Now we can actually compare them. Ordering that new list is super easy. It's 34.5, then 40, then 50. But, and this is important, when you write your final answer, you should use the original numbers. So the correct order is 345 millimeters first, then 0.4 meters, and finally, 50 centimeters. All right, let's do a quick recap. You've just picked up some seriously powerful skills. You basically have a complete toolkit now for handling any decimal ordering problem that comes your way. So, here's your new decimal toolkit. Strategy 1, always check the whole numbers first. Strategy 2, if the whole numbers are the same, just go column by column, nice and steady. And strategy 3, my personal favorite, use that zero trick to make everything the same length. It makes comparing so much easier. And that's really all there is to it. From figuring out who won a race to sorting out different measurements, you now have a strategy for everything. What might have seemed a bit tricky before is now just a simple process. So go on, you've got a new decimal superpower. Go use it.